Hello students, today we will be discussing relative atomic mass, molecular formula and empirical formula for grade 9 chemistry. An atom is an extremely small particle, therefore we cannot determine the mass of a single atom. However, it is possible to determine the mass of an element relative to another one experimentally by assigning a value to one of the atoms of a given element to be used as a standard. Using a mass spectrometer, the isotope of carbon-12 has been assigned a mass of exactly 12 atomic mass unit. The mass of atoms of all other elements are compared to the mass of carbon-12. Therefore, the mass of an atom of an element relative to the mass of an atom of carbon-12 is called its relative atomic mass. All of the elements listed in the periodic table have their atomic masses calibrated according to the one that is calculated for C12. One atomic mass, for example, is defined as a mass exactly equal to 1/12 the mass of one C12 atom, which means that the mass of one C12 atom is equals to 12 atomic mass units. All other elements in the periodic table have their atomic masses calibrated according to this ratio. For example, a hydrogen atom is 8.4% as massive as the standard carbon-12 atom. Therefore, relative atomic mass of hydrogen is shown by 8.4% into 12 AMU, leading to the answer 1, which is then rounded off to 1 in the periodic table. If we recall, what the chemical formula of a compound showed was firstly all the elements present in that compound and the whole number ratio of their atoms. These can further be divided into two types of chemical formulae. The first one known as the empirical formula and the second one known as the molecular formula. The empirical formula gives the simplest whole number ratio of the atoms present. Whether it is empirical formula or molecular formula, both of these represent the whole number ratio. The difference between the empirical and molecular formula is that the empirical one gives the simplest whole number ratio of the atoms present. For example, hydrogen peroxide has a chemical formula of H2O2. If we were to find the molecular formula, we would represent it with H2O2 because the actual ratio of hydrogen to oxygen is 2:2, versus the empirical formula to be written as HO, which is the simplest ratio of this formula. If we were to consider the ratio between carbon, hydrogen and oxygen atoms in a glucose molecule, it is 6/12/6, which makes the empirical formula the simplest ratio 1:2:1, CH2O. If we were to consider, on the other hand, the ratio between carbon, hydrogen and oxygen for a molecular formula, it would end up in the molecular formula being C6H12O6. The last and one of the most important things to discuss in this lecture is molecular mass. Molecular mass is the sum of the atomic masses of all the atoms present in the molecule. It is used for molecular compounds. For example, if there was a water molecule and we were to find its molecular mass, we would add the atomic mass of each hydrogen atom multiplied by 2 because there are 2 hydrogen atoms in a water molecule, and further added to the atomic mass of one atom of oxygen, and we would end up with the rounded figure of 18. Let's take another example of naphthalene. Naphthalene has a chemical formula of C10H8. C10H8 means that there are 10 carbon atoms, each with an atomic mass of 12, and 8 hydrogen atoms, each with an approximate atomic mass of 1, leading to a total sum of 128. This is how you find the molecular mass of different compounds.